State machines is the format that we highly recommend using when you're programming and flowcharting. It'll help keep your program very organized, and it'll make your life much easier if you stick to this format. So we'll go through a simple example. And the way state machines work is you're at a particular state and you're waiting for conditions to be met. And once they are, you do something, and then you move to the next state, and then you're waiting for another set of conditions. At which point you'll do something, and then you'll move to a different state. So you're always hanging out at one particular state, waiting for things to happen, and then based on what happens, you move to possibly different states. But it's a good way to progress through whatever task you're working with. Those things that you're waiting on, those conditions, they can be all kinds of things. They can be limit switches. They can be an analog value reaching a particular value. In our case, we're going to go ahead and just use a timer. They can be multiple things. They could be a combination of things, but in our case, we'll just use a timer. So the first thing we'll do is we need to create a tag that we're going to use for our state machine. And I'm just going to call it state, and I'll make it a UI16. And we'll put a actually I'll put a 0 into it. And the next thing we'll do, since we're going to use a timer, I'm going to go ahead and I'll start up a timer, and we'll call it my timer. Okay, make this look a little better. Okay, so now we are going to start checking for states. So we'll check, is state equal to 0, which we've told it is. We've put in that copy statement that it should be. So the first time it is going to be state equals 0. And at that point, we're going to go ahead and we will turn on a bit. We'll turn on this D1 bit. And once that's on, we'll go ahead. I'm going to do a Control C here to copy that. We're going to advance it to the next state. So it'll turn it on, and then it'll advance it to the next state. So state is now equal to 1. And we'll do this. We'll use a wire router to loop everything back. So after this, it'll loop back around. It'll check its state again, and now it's going to be state equals 1. So we need to provide something for that condition. And here's where we're going to go ahead and we're going to check some values. We're going to check has my timer advanced to 1 second yet. And if it has, let's go ahead and turn off this bit, and let's advance the state to state equals 2. Okay, and we'll connect up these wires, and we need to make sure we connect up the timer is not greater than or equal to 1 second. If we don't do that, then it's going to fall through when it gets to that no, which it will get to the very first time it does it, because it'll first go state equals 0, yes, you'll turn on the output bit, you'll copy to 1, it'll loop back around, it'll say state equals 1, which it will be. It'll ask, is the timer greater than or equal to 1, which it won't be the first time. It'll be a tiny fraction of a second. So it would go out the no path, which if it wasn't wired up, would cause the program to start over again from the beginning, which would copy a 0 into state, and you'd kind of reset your program. So you need to be sure to always wire up all of your connections. So now we need to handle the case that it is 2. So in this case, with state equals 1, it's going to keep looping around. Since I wired it like this, until it reaches 1, it'll just keep going through this loop, just checking over and over and over again, until finally it's 1 second, in which case it'll go ahead and it'll turn the output off and it'll advance to the next state. So now we're going to handle that next state, and we'll see if 2 more seconds of advance. So now my timer will be equal to 3 in this case. So the first second it took to get here, and then 2 more seconds. And what we'll do is we'll just reset the timer, and we will advance the state. We're actually going to bring it back to the first state, which is state equals 0. So again, this will cause the program, after it's already moved through this copy statement, it'll go through here and follow the no path over and over and over again for 2 more seconds until finally it's true, and then it'll reset the timer and it'll move the state back to 0. And we're going to go ahead and link up this other path. There isn't any condition in this program that it should ever follow that path, but to keep things looking good, we'll go ahead and we'll link that up. At this point, we can program, and I'll put this in debug mode, and we'll switch to value mode, and we'll run it. And you can see the state number is right here, and you can see that it hangs out for 1 second in the 1 and then 2 seconds in the 2. So 1, 1, 2, 1, 1, 2. And you can also see the output bit, it stays 1 for a second and then it stays at 0 for 2 seconds. So it's doing exactly what we want it to. So this is how you'd format your state machine. We'd really recommend you do it this way. Sometimes people ask us, hey, can you do several tasks like this in parallel? Can you do multiple state machines in parallel? And you can. And I'm going to close out of this project, and I've got another one already built up, and I'll show you the difference. I'm just going to zoom out here a little bit. The difference is I've created a second state machine, so I've got state, but I also have the state 2 I'm using for the other state machine. And instead of just having a my timer, I've got a time 2. And you'll see down here, instead of, you see I'm comparing its state here, and I'm advancing state here. In this one I'm using S2, and I'm advancing S2 over here. And instead of using my timer, which I use throughout this one, I'm using a time 2 over here. So the way you do it is you connect up all of your state machine 1 blocks to a wire router, and then you'd route them to your second state machine, and then you connect all of those blocks up together, and you'd route them back to the beginning. And that would allow you to do 2 things, 2 state machines in parallel. And in this particular example, I've still got the 1 and 2 the 1 second, wait for that, and then 2 additional seconds waiting for it in the first state machine. And in this one, I'm waiting a half second and then another half second for a second bit, doing a very similar procedure. And I can zoom out here, and I can show you that they're both running in parallel. So this is still hanging out here for 1 second, then hanging out for 2 seconds, and you'll see this one is half second, half second, half second, half second. So it's doing both of these operations in parallel. Now the actual refresh rate, where we draw all the stuff on the screen here, only happens every half second. So it sometimes gives the appearance that it's not hanging out for exactly half second, but that's just because of the refresh rate on how often we pull the device inside vBuilder. But yeah, you can see this is how you do them, and you can imagine if you needed a third state machine, you'd go ahead and you draw a third one down here, and you can do as many as you need, as many parallel operations as you need. So that is state machines.